Look at this for a second. 3 plus 3 times 3. Simple. First grade simple. There is not a single symbol on that line you didn't learn before you were 8 years old. No brackets, no fractions, no letters pretending to be numbers. Just 3 plus 3 times 3. And yet, if you showed that exact line to 100 people, you would get 2 different answers, and both groups would walk away completely certain that the other group had failed basic math. Some of you read it the way you read everything, left to right. 3 plus 3 is 6. 6 times 3 is 18. Done, clean, obvious. And you are wrong. The answer is 12. Not because you can't add, not because you can't multiply. You can do both of those in your sleep. You got it wrong because somewhere around the 3rd grade, a teacher told you there was a secret order hidden inside every equation, a rule about who goes first, and you were told to just memorize it. Please excuse my dear Aunt Sally, PEMDAS. Or, if you grew up somewhere else, BADMAS. You learned the mnemonic, you passed the test, and you never once asked the only question that actually matters. Why? Why does multiplication get to cut the line? Why does the universe insist that in 3 plus 3 times 3 the multiplication happens first, no matter what order it's written in? Who decided that? And what would happen if they had decided differently? Most people assume the answer is that it's just a rule someone made up, like driving on the right side of the road, arbitrary and enforced. But that's not quite right. And the real answer is far stranger, because it turns out this rule you resented as a kid is one of the most important agreements humans have ever made. And it very nearly wasn't this way at all. Let's start with why your brain says 18. Your instinct to go left to right is not stupidity, it's language. You spent your entire life reading sentences one word after another, and your brain quietly assumes math works the same way. First thing first, next thing next. In a sentence, that's correct. In an equation, it's a trap. Because math is not a sentence, it's a set of instructions, and some instructions are more powerful than others. And that is the first clue to the whole mystery. Multiplication is not the same kind of thing as addition. It only looks like it because they sit next to each other on the same line wearing similar symbols. Here's what I mean. What is multiplication actually? Strip away the fancy word. 3 times 3 just means 3. 3 times. 3 plus 3 plus 3. Multiplication is repeated addition. It's addition that got compressed, folded up into a smaller, denser package. When you write 3 times 3, you are not writing a brand new operation. You are writing 9 in disguise. Read that again, because it's the entire key. That little 3 times 3 sitting in your equation is not really an operation waiting to happen. It's a single number wearing a costume. It's already 9. It just hasn't taken the mask off yet. So when you follow the rule and do the multiplication first, you are not obeying some random command from a math teacher. You are simply resolving the number that was already there. You're taking the mask off before you start combining things. 3 plus the number 9 equals 12. It was always 12. The 18 was an illusion created by reading a compressed number as if it were a fresh instruction. And this goes further than most people ever realize, because the hierarchy doesn't stop at multiplication. There's a ladder. Addition is the ground floor. The most basic thing you can do to two numbers. Multiplication sits one level above it, because multiplication is just addition repeated. And exponents, powers, sit one level above that because an exponent is just multiplication repeated. 3 to the power of 3 is just 3 3s multiplied together. Each floor of the building is made by stacking up copies of the floor below it. Now look at the order of operations again with that in mind. Exponents first, then multiplication, then addition. It is the exact ladder climbed from the top down. The most compressed, most powerful operations get resolved first, and the simplest one, addition, comes last. The order of operations is not a random list somebody scribbled down. It's a hierarchy that mirrors how these operations are literally built out of each other. The rule has a spine, but knowing that multiplication is denser than addition still doesn't fully explain why we agreed to always do it first. Dense or not, we could have made the opposite rule and just used a lot more brackets. So why didn't we? The answer has almost nothing to do with a single equation like 3 plus 3 times 3, and everything to do with something you probably also hated in school. Algebra. Picture a normal, everyday algebraic expression, something like 3x squared plus 2x plus 1. If you've ever seen a graph of a curve, this is the kind of thing that produces it. Now that expression is only readable because of the order of operations. The rule tells you, without a single bracket, to handle the exponent, then the multiplications, then finally add the three pieces together. It flows. It's clean. Now imagine a world where addition came first instead. Suddenly that same expression is a disaster. You would have to wrap almost every single term in its own set of brackets just to stop it from collapsing into nonsense. Every polynomial, every physics formula, every line of an engineering calculation would drown in parentheses. Math would still work, but it would be almost impossible to read, like trying to write a novel where every word has to be individually boxed. So the convention wasn't chosen by a committee that thought multiplication was morally superior. It was chosen the way a path gets worn across a field. Mathematicians in the 15 and 1600s were inventing symbolic notation for the first time. The multiplication sign, the way we write powers with a small raised number, the letters standing in for unknowns. And as they wrote more and more, one convention kept turning out to be the least painful, the one where multiplication binds tighter than addition. It won because it made the most common expressions the easiest to write. It was natural selection for notation. And that's the part almost nobody tells you. There was no grand meeting, no vote, no year in which humanity officially declared that multiplication goes first. The rule you were taught as an unbreakable law of the universe is actually a habit that a scattered group of people slowly fell into over a few centuries because it was convenient. The mnemonics you memorized, PEMDAS and BODMAS, are little more than a century old. They're not the law. They're just a memory trick invented long after the fact to help kids remember an agreement that adults had already been using out of pure laziness and good taste. Which brings us to the strangest part of all. If it's just an agreement, then it could have been broken. And it has been. There is an entire system of writing math called reverse Polish notation, built on the parentheses-free notation invented by a Polish logician named Jan Łukasiewicz in the 1920s. In that system, you don't need an order of operations at all. There are no brackets. There is no PEMDAS. You write the numbers first and the operations after, and the ambiguity simply vanishes. There is only ever one possible answer. For decades, some of the most powerful calculators ever made, the ones used by engineers and scientists, ran entirely on this system. To them, PEMDAS was unnecessary, a problem they had solved by refusing to play the game. And here's the detail that should genuinely mess with you. Take that original line, 3 plus 3 times 3, and type it into a cheap, basic 4-function calculator, the kind you find at the bottom of a drawer. Many of them will confidently tell you the answer is 18. Not because they're broken, because they were built to read strictly left to right. They are using a different convention than you were taught. They are, by the rules of your third-grade classroom, wrong, and by their own rules, they are perfectly correct. So sit with that for a second. The answer to 3 plus 3 times 3 is not 12 because the universe demands it. Gravity doesn't care. The atoms don't rearrange themselves. The answer is 12 because, at some point, most of humanity quietly agreed to read that line a particular way. And we've been teaching that agreement to our children ever since as if it were carved into the fabric of reality. It isn't. It's a language, and like every language, it has a grammar. And like every grammar, it's a set of rules we invented that could have been otherwise, but happened to land on the version that made everything else possible. That's the thing about the rule you were told to just memorize and never question. It was never really about multiplication being greedy or addition being weak. It was about compression, about the fact that some numbers hide inside operations waiting to be revealed, about a ladder of ideas stacked so neatly on top of each other that we built the entire modern world on the order we agreed to climb them. So no, you weren't bad at math when you said 18. You were reading it like a human, one thing after another, in order. You just didn't know that 8-year-old you had been handed one of the oldest and most useful secret agreements our species ever made. And nobody ever told you it was an agreement at all. They just said, "Please excuse my dear Aunt Sally." And you did, for the rest of your life, without ever asking who she was.